Welcome back to Arxflix. Today, we're diving into a captivating research paper titled Object-Centric Learning with Slot Attention. This paper presents a novel module aimed at improving abstract reasoning from low-level perceptual features by focusing on object-centric representations. The authors introduce the Slot Attention module, a differentiable interface designed to produce a set of task-dependent, abstract representations, called slots. These slots can bind to any object in the input by deploying a competitive multi-round attention mechanism. Essentially, slot attention allows a neural network to extract object-centric representations from complex scenes. Let's look at Figure 1, which illustrates the slot attention module. It shows how the module maps a set of input feature vectors to a set of slots that describe objects or entities in the input scene. Traditional deep learning models often struggle to capture the compositional properties of scenes. They tend to learn distributed representations that aren't necessarily structured around distinct objects. This is where slot attention makes a notable difference. The paper's main contributions include the following. First, it introduces the slot attention module, a simple yet effective component for interfacing between perceptual representations and set-structured, abstract representations. Second, the paper demonstrates the application of slot attention in unsupervised object discovery and supervised property prediction tasks, showing competitive performance against state-of-the-art methods. Third, the authors highlight slot attention's efficiency in terms of memory usage and training speed. Slot attention operates using an iterative attention mechanism. It starts with a set of randomly initialized slots and refines them over several iterations to bind each slot to different parts of the input. Equation 1 shows how the softmax-based attention mechanism helps slots compete to explain parts of the input. Equation 2 demonstrates how the input values are aggregated to update the slots using a weighted mean. These updated slots can then be used for various downstream tasks. Figure 1b showcases how the slot attention module can be embedded within an architecture for unsupervised object discovery. Here, an autoencoder setup encodes an image into slot representations, which are subsequently decoded back to reconstruct the original image. This setup allows each slot to capture and potentially specialize in different objects in the scene. The authors use datasets like Celivar, multi-D sprites, and tetraminos to validate their approach. In terms of performance, slot attention matches or outperforms the state-of-the-art models like Iodine and Monet, delivering higher adjusted RAND index (ARI) scores which measure clustering similarity. Figure 1c illustrates the set prediction architecture, where slot attention is used to predict properties of objects in a scene for supervised tasks. Each slot attends to a different object, making it easier to classify objects separately. For this task, the authors use the Celivar dataset. They demonstrate that slot attention is capable of learning object properties and positions with high accuracy, outperforming competing models like deep set prediction networks, DESPIN. Additionally, this module is robust and can handle input with varying numbers of objects. Let's look at the attention masks produced by slot attention. Figure 6 shows attention masks for two Celivar images. Notice how each slot's attention map clearly segments different objects, even though the model wasn't explicitly trained to produce segmentation masks. In summary, the slot attention module presents a significant advance in object-centric learning. It's not only more memory efficient and faster to train, but also highly competitive with existing approaches. Future steps include extending slot attention to video data, other data modalities, and exploring downstream tasks like control or planning. Thanks for tuning into Arxflix. Don't forget to subscribe for more paper summaries. Leave your thoughts on this paper in the comments below. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.